All right, so this is video number 14, and this is chapter 8, section 3A. This is going to be broken up into at least A and B, possibly a C section. And this is about the polar coordinate system. And this is a completely different type of coordinate system. Coordinate obviously means graphing. And so what you guys have seen in your career so far is the rectangular coordinate system. And that rectangular coordinate system, as you well know, is your X and Y coordinate system, and it's based on a rectangular grid, right? Well, that is not the case with your polar coordinate system. And the polar coordinate system is based on an R and a theta, and it's based on angles. And what it looks like, your polar coordinate system, looks like it's got a base in the middle. And then just really quick, I'll just draw, it's kind of got this like bullseye type of deal in here. And it's got a round type of, it literally looks like a bullseye. And you're going to be plotting on that type of thing. So here's an example of one right there. Okay. So if you see a round graph like that, that's the polar coordinate system. And very, very different than what you've seen in the rectangular coordinate system so far. So I'm going to give you some words and some information and then show you really quickly how to graph in there. And then your next video is going to get into kind of going back and forth between these two things. So going back and forth between the rectangular coordinate system and the polar coordinate system. Okay, so we're going to add a screen here, and this talks about forming the actual polar coordinate system. So to form the polar coordinate system, just so you kind of have some background in what's happening. In the plane, fix a point O called the pole or the origin. And construct from O an initial ray called the polar axis. Okay, so before we go any further, let me show you what that means. So what we do is we've got we're fixing a point O. So there's this little point O in the plane. And then we are running an initial ray out of it, and a ray goes on and on forever. That is called the polar axis. And that's all we know so far, okay? More information, though. All right, so then each point P in the plane can be assigned polar coordinates and those polar coordinates are an ordered pair, are theta instead of xy, as follows. Excuse me. So I'm going to actually, I bet you wish you could do this. I'm going to actually move this down a little bit. And so, oh, good. I don't know if you can hear the woodpecker pecking on my house. It's real annoying. So we are going to have from this point, we're going to have this point P is going to come out of here. And here's what's going to happen. So we're going to have 1 R is a directed distance from O to P. And so this represents R. That is the directed distance from O to P. And then 2, you have theta, which is a directed angle and it's counterclockwise. And it goes from the polar axis to the segment OP. So that means counterclockwise, you have that angle in there, and that is your theta is your directional angle in there. Okay, and this point P up here is represented with this point R theta. So that's what's actually happening. That doesn't really help you actually graph these though. So here's what's going to happen. Let me kind of quickly draw one of these, and I'll draw it kind of specifically on here. So I'm going to start out with 2 lines, which are your polar axis. Well, they actually represent, if you think about your unit circle, these actually represent like your 0 degrees, pi over 2, or 90, pi, and 3 pi over 2. So they go around that way. And then with your polar coordinates, we have these circles that kind of come out equidistant from each other. So we'll explain how this works. And then you also know, let's see, let me change some. I'm going to choose that, but I'm going to make this line a lot skinnier. And I want to change the color of that line, I think. Oh, red is fine. Okay, so that's good. All right, so we have a line would come out there for 45 degrees, 30, and 60, right? And those would typically just kind of continue straight across here. Right, so we're just kind of constructing this. You should be constructing this on your paper also while I'm doing this. I hope this one isn't giantly fat. Oh. Poop. All right, let me fix that. That's that guy. All right, so really quick, these are going to be pi over 6, which is 30, pi over 4, which is 45, pi over 3, and then you go around the unit circle. So if I had a point, which, oh, also, you need to know this. These circles here, the concentric circles, this one has R of 1. So that's a radius of 1. This one is R2. This one is 3. R is 3 because it's the third one. This one, R would be 4. If there was another one, it would be 5, right? So you would just keep on going around the circle like that. All right, so here's how this works. If you have a point, remember the point, any point is R theta. So if you have one that is 2 pi over 3, you go to the pi over 3 angle, which will be here, and then out to the second concentric ring, and that would be that point, 2 comma pi over 3. All right. If you had one, let's switch to degrees because that's easier for all of us. This would be 330 degrees. So if you had 4 comma 330, you'd find 330. You'd go out to the 1, 2, 3, 4th ring, and that would be that point. All right, so let's go and plot these points over here. I've got some practice for you. All right. We want to go to 315, which is between 300 and 330, and then go to 4. So here's 315, and then we're going to go to 4. That would be that point. All right, well, this one, 0's the angle. That's here, out to 4. All right. 3 pi over 4. It's not marked on this, but just check your unit circle. That's here, down to 1. Okay. Here, I'm going to go to negative 135. Remember, you're going this way. That's going to be out here and up to 2. All right. Excuse me. All right, and that's all you got to do for these. So we're just going to plot some points. Toodaloo for now.